Hello everyone. Today we are going to talk about the models of the atom. So we want to be able to identify the characteristics of the different types of models that have been created to explain how the atom is structured. So there are several different types of atoms. We're going to start with J.J. Thomson in 1904. He had the plum pudding model and it approximated the size of an atom. He thought that the pudding like the atom was made up kind of like a pudding. It was smeared with positives and the electrons were sprinkled throughout like plums in plum pudding. We knew that atoms were neutral because electrons can be ejected, so there must be some kind of positive. So he thought they were just kind of sprinkled throughout. Then Ernest Rutherford expanded on that model, and he had a very thin foil of gold that was blasted with alpha particles. This is key right here. Alpha particles are helium, and most of the particles passed straight through and glowed on a phosphorus screen, but some small percent bounced in random directions. So what he figured out was that the atom was actually mostly empty space, but the nucleus was very dense and was positively charged. According to this model, the atom should emit a continuous spectrum of light, but it only makes specific colors. And that leads us to Niels Bohr and those specific colors. He came up with the absorption spectrum. He realized that when white light shines into a gas, it gets excited. Some of that light passes through and will be used by electrons. That light does not pass through the gas. It shows up as a dark line on the other side. And when gas is heated, it gets excited and the electrons will absorb the energy, then give it off as a glow. This shows up as a colored line, as colored lines. The absorption and emission lines of an element are at exactly the same frequencies as each other. You can use them to identify the type of gas you're working with. So here's the emission spectra of all the elements. You don't need to know this, but it's kind of pretty. And here's another example. So then Bohr also proposed a quantized shell model of the atom. In Bohr's model of the atom, electrons traveled in a defined circular orbit around the nucleus. So here's the nucleus, and the electrons traveled in certain shells of the nucleus, and it was labeled by the integer n, the quantum number n. Electrons can jump from one orbit to another by emitting or absorbing energy. And in the Schrödinger cloud model, which is a little bit closer to what we accept as truth, electrons buzz around the nucleus in a cloud of probabilities. So we know that the electrons are likely to be more like here and here for a certain atom, or more like this to expand on that shell model. So there are shells, but it's in certain places. There's a probability of where those electrons might be.